So today we're actually going to be solving the log equation. So what we did yesterday was substituting letters in for those logs, condensing them. Today we're actually going to be condensing and solving when we have logs, more than one log. So I just relisted the different rules for you. Remember, product rule, we're adding. Quotient rule, we subtract. And power rule, we bring that power up to the front and we multiply it by the log. Okay? So we do have some steps to evaluating log equations. So what we need to do here is we're first going to condense each log into a single log with the same base on each side. So we're going to actually have a log is equal to another log. So what we need to do is condense each side, make sure they have the same base, and at that point we can drop the common base or drop the entire log, just like we did before with exponents, and we'll be able to solve for x. Okay? So we're pretty much doing the exact same thing that we did with exponents in 8A, but now we're doing it with logs instead. But the idea is still the same. So, our instructions here are any problems involving E, leave your answer in terms of E. Do not approximate, and it does let you know that some problems will have no solution. Okay, so if you get a no solution, don't freak out. None of our examples do, but on your homework you might. Okay, so number 1. We have log base 2 of 3x equals log base 2 of 96. Are these each condensed as much as possible? Yeah, each side, right? Each side separately. Do they have the same base? 2 and 2? Yes. So what we can do is we can drop the log, and we can just rewrite it as 3x equals 96. Yes. Okay, so now we divide both sides by 3, and we get x equals 32. And that's it. So same idea as what we did in 8A. Now, though, we don't have to rewrite each of the logs as an exponent. We can just drop the logs if the bases are the same. Okay? If the bases are not the same. Okay. Okay, number 2. We need to condense the left-hand side first. What rule is that? Power rule. So the first thing we're going to do is rewrite using the power rule. So that's going to be log base 5 of 4 squared equals log base 5 of 2x. Do I have the same bases? Yes. Yeah, log base 5. So we can drop those bases. Now remember, we're not dividing, we're just dropping the bases because they're the same. And we have 4 squared equals 2x. 4 squared is 16, so we have 16 equals 2x. Divide both sides by 2, so x equals 4. X equals 8.
I'm a human, I make mistakes.
Okay. Make sense? You guys are okay? Yeah? Okay. Number 3. Log base 6 of 3 to the x equals log base 6 of 81. Do I need to condense it all on this one?
No.
No. Do I have the same base?
Yeah.
Yes. So I can drop those bases. So I'm just left with 3 to the x equals 81. Now we're going back to 8A again. I need to rewrite 81 as a base of 3. So that's going to be 3 to the x equals 3 to the 4th. So I can drop those bases again. So x equals 4. So we actually had to do the same process twice in this problem. But same idea. Okay, number 4. I have log base 2 of 3x plus 7 equals log base 2 of 4x minus 8. Do I need to condense it all? No. But do I have same bases? Yes. So I can drop those bases. So I'm left with just 3x plus 7 equals 4x minus 8. We don't even have to. Let's do get all the x's on one side and all the numbers on the other. So what do you guys want to do first? Get the x's. I would say get the x's on the right, because when I subtract 3x from both sides, that gives me 7 equals 4x minus 3x is 1x plus 8, or no, minus 8. So we add 8 to both sides. Oops. Oh my goodness. So x equals 15. I don't know why I crossed it out here. Yeah, I know. X equals 15. Okay? Okay. Moving right along, number 5.
Do this.
Okay, number 5. Do I need to do any condensing here? On which side? The right-hand side. So I'm going to rewrite the left right now. Log base 4 of x minus 2 equals log base 4 of 25 divided by 5. Okay, so I can drop those bases now, right? So that's going to be x minus 2 equals 25 over 5 is 5. So I did 2 steps in one here. I dropped the bases and I divided. So I'm going to add 2 to both sides. So x equals 7.
Way too easy.
Right?
I don't want to say anything more because then I get it.
Okay. How about number 6? I have natural log of 2x plus 3 minus natural log of x minus 2 equals natural log of 4. What rule do I have to do here? Huh? Quotient rule. So this is going to be natural log of 2x plus 3 all over x minus 2 equals natural log of 4. Alright, so what can I do next?
You can cross out the 2 and make it just a 1, right?
Well, I have natural log of 2x plus 3 over x minus 2 equals natural log of 4. Are my bases the same? They're natural logs, right? So I can cancel those bases. So I am left with 2x plus 3 over x minus 2 equals 4. Okay. Now, I need to get rid of this x minus 2.
Multiply.
So what I would do is I would multiply both sides by x minus 2, because then these will cancel, right? I did not leave myself enough space. So what does that give me? On the left-hand side, it gives me 2x plus 3 equals distributive property 4x minus 8. Okay, so what do you want to do next? Let's subtract 2x from both sides. So that is 3 equals 2x minus 8. Add 8 to both sides. So 11 equals 2x. And then last, divide both sides by 2. So x equals 11 over 2. Okay. Little bit trickier. But we do have to remember that because we have a binomial in the denominator, we have to multiply both sides by that entire thing. Remember, it's all of it or none of it that cancels. So we multiply both sides by the entire denominator so that we can cancel them out. Okay? And then we use distributive property over here. You guys okay with that? Okay. Okay, last two for this one. Number 7. Log of 3 to the 2x equals log of 27. Are my bases the same?
No. Yes.
Yes. So we can cancel those bases. So we're just left with 3 to the 2x equals... Can we rewrite 27 as a base 3?
Yes.
3 to the 3rd. Okay, so now we have bases of 3, right?
Yeah.
So I can drop those bases, and I'm left with 2x equals 3. Divide both sides by 2. So x equals 3 over 2. Last one, number 8, utilizes a lot of rules. What rules do you see?
Power.
I see power rule, right? So we need to bring 2/3 up to the 27, and there's also quotient, right? So this is log base 7 of x equals log base 7 of 27 2/3 over, come on, 5. So I did power rule and quotient rule in the same step. Are you guys okay with that? I brought the power of 2/3 up, and then we also had a quotient rule, so I divided 27 to the 2/3 by 5. So what we can do now is we can drop those bases of log base 7. So that gives me x equals, how can I rewrite 27 to the 2/3? Cube root of 27, and then all of that squared, divided by 5, right? Which equals, cube root of 27 is 3 squared over 5, and 3 squared is 9, so 9 over 5.